Our today's topic is applications of first order differential equations. First one is Newton's law of cooling and heating. A thermometer is removed from a room where the temperature is 70 degrees Fahrenheit. So inside the room, the temperature is 70 degrees. Now, of course, if the temperature of the room is 70 degrees, so thermometer shall read the same. And is taken outside. So thermometer is taken outside where the air temperature is 10 degrees. So here the temperature is 10 degrees. It means the thermometer will start cooling down because inside the room the temperature was higher, outside the room the temperature is lower, so it will start cooling down. The 70 degrees temperature will start coming down. After 1/2 minute, the thermometer reads 50 degrees. What is the reading of the thermometer at t equals 1 minute? At time 0, the temperature is 70 degrees. At t equals 1.5 minutes, the temperature is 50 degrees. What is the temperature at time 1 minute? What is the temperature here? Also, how long will it take for the thermometer to reach 15 degrees? So let's say this is 15 degrees, just for instance. What will be the time? Okay, so there are two questions. 2 or 3 things are given and 1 or 2 are asked. So we know that at time 0 the temperature was 70 degrees. At time 1.5 the temperature is 50 degrees. Temperature outside is 10 degrees. These are the informations we know. And we have to answer at time 1 minute what would be the temperature, okay, what was the temperature, and how long will it take to reach 15 degrees. Maybe further, of course, it's 1.5 is at 50 degrees, then it could be, what do you think? Can we guess? More important and more interesting question here is, I would really like you to think, how far will it drop? Let's say if we leave it forever outside and the temperature does not change outside, then how far will it drop? Will it go to 0? Think about this question. Will thermometer read 0 at some point? Let's first solve it and then we will answer this question as well at the end. So our equation is here. This is the equation we are going to use. Newton's law of cooling it is called. The temperature, capital T, time is small t, and this one, this Tm, is called temperature of surrounding. Okay, temperature of surrounding, and it is a constant. Okay? Tm is a constant, temperature of the medium around the object. Okay, in our case, Tm is, so in our case Tm is 10 degrees because outside temperature is 10 degrees, so Tm is 10 degrees. Okay. K we do not know yet, but we do know that T of 0 equals 70. We do know that T of 1.5 equals 50. Okay. How do we know that? Because at time T0 temperature is 70, and this one we know because at time T equals 1.5 temperature is 50. These are the two conditions which will help us find this K and one more constant which we will see during the solution. So let's solve it. D capital T over D small t, K times T minus 10. Okay. This the value Tm I have put already. This is Tm. Okay. This is a separable equation, so very easy to solve. D capital T over T minus 10 equals K dt. So this is equal to log of T minus 10 equals Kt plus C1. So we take both sides into e power Kt plus C1. Left hand side e and log cancel each other. On the right hand side we can separate the two terms, e power Kt and e power C1. Now I can write T equals This e power c1 is a constant because c1 is a constant, so e power c1 is also a constant, and I can rename it and I can write c e power kt plus 10. 10 is coming from this side. So here what I've done is I have done e power c1 equals c. Okay. We have two unknowns, c and k. We don't know k and we don't know c, but we do know two conditions, this one and this one. They will help us find c and k. So let's use them one by one. T of 0 equals 70, that implies 70 equals c e raised power 0 plus 10, that means c equals 60. So our solution becomes 60 e raised power kt plus 10. Okay. Now we use the second condition, which is t of 1.5 equals 50, which means small t, the time, equals 1.5, capital T equals 50. For use again, 1.5 k equals 4 by 6, okay, or 2 by 3, because we want the value of k, and log can cancel e, so we take log on both sides. 1.5 k equals log of 4 by 6, and this means 1.5 k equals log of 4 by 6 minus 0.270. So our final form of the solution becomes t equals 60. Was it 60? Yeah, 60 e power k is minus 0.270 t plus 10 time t and temperature capital T. Now we can answer any question from here. Let's say our first question was, what will be the temperature at time t equals 1 minute? That's very easy to answer now. So we put t equals 1 and we see what is the temperature. 60 e power minus 0.270 into 1 plus 10, and that is equal to 8 degrees. 5.8 degrees Fahrenheit. That looks good because at 70, 0 it's 70, 1 minute 55.8, 1.5 it goes down to 50. Now we have to find this time when it reaches 15 degrees. 15, and we have to find small t. Yeah, it's the other way around this time. And then we do is, this means 15 equals 60 e power minus 0.270 t plus 10. So this t we have to find, just like k, just like this k, we will use exact same trick. We'll send the 10 to the other side, so it will become 60 e power minus 0.270 t equals 5 log of e power minus 0.270 t equals log of 5 by 60, and this using calculator tells us 9.2 minutes. So it took 9.2 minutes to reach t equals 9.2 minutes. So now look at the story again. At time 0, when the thermometer was taken outside, the temperature was 70. At 1 minute, it dropped to 55.8. At 1.5 minute, it dropped to 50. In 9.2 minutes, it dropped to 15 degrees. Now let's go back to our question here. The very important question. Will thermometer read 0 at some point? Can you try this question? So now I am asking you that what will be the time when temperature will be 0. So can you solve this question literally? So temperature 0, what will be the time? What do you say? Pause the video, think about it. Or here's the alternative question. How far down will it drop? Will it stop at some non-zero number? Will it stop before 0, somewhere before 0? What point will it stop? Can we tell? Yes, we can tell. What we can tell is, let's write our solution again. 60 times e power minus 0.270t plus 10. We say when t is very large, okay, t is very large after a very long time, after a very long time. How do we say a very long time or something like this in mathematics? We say limit. We say, do you remember limits? They were in calculus. We say limit t approaches infinity, 60 minus 0.270t plus 10. What is limit t approaches infinity when e has a negative power? It is 0, okay, because 1 over e power something, so that will go to 0 and our answer will be 10. That should be the answer actually. Why? Because you see the outside temperature is 10 degrees. Thermometer cannot read below 10 degrees. It has to stop at 10 degrees, okay? Because the surrounding temperature is 10 degrees. So that's what our solution says. So it means our solution is correct. Okay? But this is some extra information. This is not part of the question. Some extra information. The population of a community is known to increase at a rate proportional to the number of people present. Population present at time t, okay, is known to increase at a rate proportional. So what is the rate? Rate is the change in population with time, dp by dt. That's the rate, and it is proportional to the population present. So dp by dt is proportional to p. Okay, rate of change is proportional to the population present. Okay, so that now we use a proportionality constant to write it in with the equal form, with the equal. So let's say k is the proportionality constant. So now we have our equation. Before we start solving the equation, let's read the rest of the question. We are given some conditions in the rest of the problem which will help us find these constants k and the integration constant c. If an initial population of P naught has doubled in 5 years, so there are two conditions within one sentence. Initial population means at T0, population was P naught. P naught is a constant. Note that P naught is a constant, and we will treat that as a known constant. Okay, P naught is a known constant. Also, they said that it doubled in 5 years. So at t equals 5 years, doubled in 5 years. So what does that mean? At t equals 5, p becomes 2 p naught. Okay? Doubles in 5 years. So these are the two conditions we will use. One says p of 0 equals p naught. The other says p of 5 equals 2 p naught. Okay, let's solve the equation. dp by dt equals k times p. Clearly it is separable, where we can rename this second constant and we can write c e power k. Right, so now we have two unknowns here, c and k, but we also know two conditions. we can use them to solve or find out these unknowns. And once again, remember that P0 or P0, as I read sometimes, is a known number. Okay, let's say the initial population was 100,000, 10,000. So P0 is like that number. Okay, but it looks like as a in the form of a variable, but it is not. So P0 equals C e raised power k times 0. We put t equals 0. Okay, for this condition to use, we use, here is the value of t and this is the value of p. So we use both the values, and that tells us that c equals p0, okay, because e power 0 is 1. Here, this e power 0 is 1. Right, it means our solution becomes p equals p0 e power kt. We still have to find k, so now we use the second one. P of 5 equals 2 p0. Again, we have, this is the value for t and this is the value for p. Just like any condition works, this is the value for independent variable and this is the value for dependent variable. So now we get 2 p0 equals p0 e power 5k. P0 can be cancelled from both sides, division, and now we get 2 equals e power 5k, or in other words, log of 2 equals 5k 134t. Now this has two variables only. Remember, this has only two variables, t as time and p as population. Once again, we are not treating p0 as a variable because this is a known constant. We know that whatever the value is, it is known. So is there any other question in the statement? How long will it take to triple or to quadruple? So there are two questions here. First question is how long will it take to triple? Triple means 3 times. So we have to find t if p is 3p0. So we write 3p0 equals p0 e power 0.134t. And that means 3 equals e raised power 0.134t. Again, using the same trick, take log on both sides to cancel e power 134t. And that is, I'll write one step directly because this log and e cancel, and then we divide 0.134 because that's kind of obvious. 0.134 log of 3, and that tells us 7.96 years. How long will it take to quadruple? Second question. How long will it take to quadruple? Well, that's almost exactly the same. You can complete it yourself. So I'll leave this as an exercise. Just this 4 will change and the rest is exactly the same. Just for fun, can you tell me 7.96 years is how many years and how many months? Just for fun. Is it 7 years and 96 months? Pause the video, think about it. How many years and how many months does it make? 7.96 years. 7 years, obviously. 0.96 multiplied 12. That is, how long can you continue? Well, that's just for fun. The equation that represents this electric circuit is given by Ri equals e power t. L is the inductance, okay, inductor. It represents the inductor here. Okay. L is the value of this inductor. R is the value of this resistor, and E is the value of power source. Okay. So let's see a question on this one. Right. So our problem is a 12-volt battery is connected to an LR series circuit, okay, one like this, in which a 12-volt battery is connected to an LR series circuit in which the inductance is half Henry and the resistance is 10 ohms. Determine the current I if the initial current is 0. So this will going to initial current is 0 is going to serve as our initial condition. The rest are values only. E equals 12. This is the volt battery, and then L equals half Henry, and then R equals 10 ohms, and that's all we need. Di by dt E plus Ri. Okay, I'll put the values directly into the equation. So this is half di by dt, 10I equals 12. Clearly, this is a linear in the variable I. The first thing we need to do is divide by half. So we actually multiply by 2 to get rid of this half. And that is our standard form. Right, this is a linear equation. So we find if equals e power integral 20 times dt, because e power 20t, because our p of t in this standard form is 20, okay? And q of t is 24, but we generally don't need q of t. Right, multiply the equation with e power 20t di by dt plus 20 e power 20t I equals 24 e power 20t, and that is d by dt of I times e power 20t equals and we integrate with respect to t. I times 20t equals 24 over 20 e power 20t plus c, or we can write I equals 6 by 5 e power, well, this will vanish, plus c e power minus 20t. Okay, we divide by 20 in this step. Divide by e power 20t. Now we go back to our initial condition. Initial current is 0. So that means I of 0 is 0, which means t0 at time 0, I is 0. So in other words, 0 equals 6 by 5 plus c e power 0. So that gives us c equals minus 6 by 5. I becomes 6 by 5 times 1 minus e power minus 20t. Okay, just take the common. C is minus 6 by 5, so take 6 by 5 common. And that completes our problem.